Searching for life. No matter what kind of life we are looking for, it is likely that we will find the necessary elements on almost every planet, moon, asteroid, and comet in the universe. These elements must be present in molecules. These molecules can be used as ready-made building blocks for life. Studies of meteorites and comets suggest to us that organic molecules are widespread among both comets and asteroids. Because we know that every world was once pelted by asteroids and comets during its early history, every world should have received at least some organic molecules. It is also possible that interplanetary dust may have also contained organic molecules that rained down on young worlds. The only caveat is that these organic molecules tend to be destroyed by solar radiation on surfaces lacking protective atmospheres. Given this, it makes sense to start searching on worlds with organic molecules that are likely to be involved in chemical reactions. We should focus on worlds that have either an atmosphere, or a surface, or a subsurface liquid medium such as water. But life requires more than just a source of molecular building blocks. It needs an energy source to fuel metabolism. Earth life happens to use a wide variety of energy sources, some of which include sunlight from photosynthesis, the consumption of organic molecules, or chemical reactions with inorganic compounds. Though sunlight is available everywhere in our solar system, the further away you are from it, the weaker it gets. Therefore, in order for photosynthetic life to survive, the life itself would have to be much bigger than Earth life and more efficient at collecting light. Chemical energy sources also place constraints on life. The only way that chemical reactions can occur, though on a wide variety of circumstances, is if the potential reactants are brought into contact with each other. This means that the ongoing reactions necessary to provide energy for life can occur only on worlds where materials are continually being mixed. On a practical level, this probably requires either an atmosphere to mix gases or a liquid medium to mix materials on or below a world's surface, the same requirements we found for obtaining the building blocks of life. In addition to organic building blocks and energy, one more ingredient is essential to all life on Earth. Water plays 3 vital roles for Earth life. It dissolves organic molecules, it allows for the transport of chemicals, and it's involved in many of the metabolic reactions. It's difficult to imagine life in the absence of a liquid substance to play these roles. But could these roles possibly be fulfilled by some liquid other than water? No one really knows for sure whether other liquids could support life in the absence of liquid water, but there are a few constraints to consider. A substance that might fulfill the roles of water must, like water, be fairly common. Several common substances such as ammonia, methane, and ethane might take liquid form on colder worlds. Although we cannot rule out these other liquids, water has at least 3 advantages that make it seem far more suitable as a liquid medium of life. First, water remains liquid over a wider and higher range of temperatures. Second, solid water can float. Third, the charge separation of water molecules allows for types of chemical bonds that are not possible with other liquids. Okay, so let's rewind and review. The 3 basic environmental requirements are molecules, energy, and liquid. The first requirement is probably met by most worlds. The second narrows possibilities, and the third is a strict necessity. Keep in mind that everything we know about life comes from the study of life on only a single world, our own. Nevertheless, a search for life must start somewhere.